Okay. Hi, everybody. This is Xiaopu. Today our group present connecting network. So for this model, we will learning the follow task. Look like how to connect the local network to the AWS cloud, and how to connect the multiple VPCs. How to connect the VPS in the AWS cloud uh, u- using the VPS peering, and how to connect how to scale VPS in AWS cloud. Yes. Uh, So in this model, we will presentation the following section look like scaling or VPC network use AWS and transact gateway, and connect AWS we use the peering, and use the remote, and uh, connect the using AWS well architecture framework. And we also have some activities look like configure AWS transit gate routes. And we also have the knowledge check for the 10 question and example. And in the end, we will have the hands-on lab. So for this slides, uh, just show us uh, as a cloud architecture designing connect networks. So we should have the flavor capability, and we should set up our deploy all the stuff, and connect the networking. So for this slide, we scaling your VPC network with AWS Transact Gate. So for this slides, yeah, we try to learning the two structure with the networking designing with the multiple VPS. So for this one, either the name either full mesh architecture, and another one is hub and spoke architecture. So So for this one, either introduce for us what's either AWS Transact Gate. So just in the high level to understand the Transact Gateway just look like in a city we have different bus route. So maybe look like in the commerce, similar commerce we have blue, green, and red, and they have the access look like in the tower cafe towers building. They meet each other, so student can go the towers and take the three bus to anywhere in the commerce. So for this slides, we are try to present centralized routing pattern for the outbound traffic. So you can see in here we have the transaction gateway, either our center can access for to the different VPC1 and VPC2. So for this one, Yeah. So this one is the same the previous the slides. They can connect the transact for the VPC one and express VPC, and in here we also have the subnet. And so for this one is the transact gateway peering. Uh, we can see in the middle is the transact gateway, and in the left part and the right part we have two Amazon account, two we have different AWS account and different region and different VPC, and they are in the equal. They are equal. We call that peering. So why we the same thing, but we use the different region to set up because we just look like we have American customer use our app, and we also have some people in Canada, Australia, India, Bangladesh, China. So we want to set up in the region, in the local database. So some people in China they can access the data very fast, no delay. And also, if somewhere have the big storm, look like this couple days we have the storm. So if the storm broken the region A, but we also have the region B the data, so they can help us save the data. So for this is just a demo for us the company group of department of for the user case. Yes. Yeah. In this company they have the three department, and in the each department they have the different VPC. So for this one is we have the active for configure AWS transaction gateway route. Yeah. And yeah. Yeah, center I said the transaction gateway just look like the central the access look like a center, and yeah. Uh, yeah. So for this slides, we configure the VPC road table, and for the they show us so which routes we need is necessary to connect for each other VPC, and we can see the VPC ID and CID. So the ID just look like the personal ID, just for example, and the CRD look like address, look like my apartment address in this town, and the the VPC road table ID, yeah, they have the different ID. Yeah, and this is the destination. For example, we buy something from Amazon, and we have we should send that for different people house. So we check the address and the ID, so the customer can deploy. And what is the table target is what we want to send or receive the something for the different customer, different transaction. Look like I buy some buy a bottle of water, and they check this table, and for my information, and they send the target for me. Yeah. So this slide also show transaction gateway route table destination and transact gateway route table target. So just look like the example. Uh, which 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 apartment we want to go and which way we want to choose. So for this is the VPC route the table just look like yeah the before the slides they give us all the detail to tell the internet how choose which way and delivery for what thing for others. So for this key takeaways, so the gateway scaling your VPC network with the transaction gateway, and we have the centralized the region route to complicated to connect VPCs, and transaction gateway can be pairing with other transaction gateway in other AWA regions and AWS account. So this one they just tell us for each account and each region they are equal for each other. They have same power. And for this one, either transaction gateway support thousand of architecture. So architecture attachment. Yes. And for this one, either they show us what's the charge for the per hour, and they depends how many number of connectings they charge for us. The be yes, based on this, how many number of connecting and traffic that flows, they charge us. Okay, thank you. Hi, sir.
Thank you, Joe. So the next part will be covered by me. So let me share my screen. Thank you, everyone. I am Abil Shah, and so I'm covering the connecting VPC in AWS network with VPC pairing. So here, as we see that different VPCs from two different AWS account and to other region are connected through the VPC pairing connection. So VPC are connected through the VPC pairing connection. So there are six VPC pairing connection, and how we can connect this. So for establishing a VPC pairing in the route table of VPC A, we have a entry of VPC pairing connection, and the address is the VPC-B's IP address. And in the same way, VPC-B route table needs a entry in its route table, whose IP address is the VPC-A's IP address. So here we can see that VPC-A is connected with VPC-B through VPC-AB pairing connection, and VPC-B is connected with another pairing connection. And it does not means that VPC-A is connected to VPC-C, because VPC pairing does not support transitive pairing. So if we want to connect the VPC A and C, then we need another VPC pairing connection to A to C. So we can using the VPC pairing connection, we can request for a specific route. So here in the VPC-A subnet, in one subnet, we are connecting to another VPC-B subnet's EC2 instance, and we just take the public private IP address of this instance. So in the VPC-A subnet route table, there is a entry of private IP, uh, and the rest of the part is and VPC B has another connection of VPC A subnet connection ID. So what are the use cases of VPC centralized resources? So there are three examples, like in some corporate office in the in some corporate office, we have so here we can see that we can pairing one VPC to access the centralized resource. Like we have a file server. These are the use cases. We have a file server. We want to connect this VPC with the other VPCs, but we do not want to the other VPCs can send the traffic to other pairs, like VPC VPC A and VPC B is connected with the centralized VPC, but VPC A and VPC B cannot interact with each other. Okay, they cannot send traffic. Another example is like customer shared VPC. So we have a customer VPC, and each customer actually connected with their VPC with the centralized VPC. So we actually do not want to send. We cannot allow them to communicate each other, or the routes that they use, it should not seen by the other VPC. Same as the Active Directory. So in the next slide, we can see that we can use private link architecture to VPC connectivity. So when we actually use this, we use this architecture when CIDR block are overlapping. So what we do, there is a service provider VPC and a consumer VPC. So this consumer VPC has a VPC endpoint, elastic network interface, and the service provider has a network net balancer, and they are connected with their EC2 instances. So if we connect these two part, then no peering connection is needed. So these actually sometimes actually very helpful when the CIDR are overlapping. So here is the summary. So VPC pairing establish a one-to-one pairing network connection between two VPC to provide private network traffic routes. VPC peering does not have any extra cost, but transferring data across availability zone and region have some cost. So VPC peering can provide network traffic flow between different AWS account and AWS region. VPC peering does not support transitive VPC peering relationship. And if a VPC is overlapped CIDR, then we use a private link with network load balancer to establish VPC connectivity. So here in the next part, actually we have labs, so we will do it later. It will be covered by Chase. So uh, So connecting to your remote account with AWS side-to-side VPN. So till now, we know how we can connect two VPC or multiple VPC. But if we have any corporate environment and there is a on-premises network, then how we can connect it to the VPC. So for this region, for this architecture, we have to follow this, create a secure connection between an on-premises customer gateway and AWS virtual private gateway for VPC access. Create two encrypted internet protocol security VPN tunnels for each connection across multiple availability zone, and it actually charges VPN connection hourly. So here we can see the architecture, and each uh, each of the uh, each of the marking is the setup, and let me discuss about how the traffic goes. So in the corporate environment, on-premises network is customer gateway device. So this customer gateway device is connected with the customer gateway, which is provided by the AWS cloud, and this customer gateway flow the traffics through the internet VPN, two internet VPN connection. The first one is for the primary traffic, and the second one is the for the maybe for the redundancy. So this two internet VPN connection is connected with the route table, and the route table actually have a connection with the virtual private gateway, which actually allows us to connect the VPC. So in the next slide, we can see that in a corporate environment, we have multiple on-premises network. So how we can, so since we are using the public internet, so there might be some problem. So for that region, we can uh, connect it is VPC's customer gateway with a virtual private gateway. So we can then we can here just connect with each other, and we can communicate with each other. Okay. So we can accelerate side-to-side VPN connection. Like in this diagram, in a on-premises gateway, network, customer gateway is connected with the AWS global accelerator, which is established in the edge location. So this AWS Global Accelerator is connected with the Transit Gateway through uh, Transit Gateway VPN attachment, and the Transit Gateway is connected with the VPC through the Transit Gateway VPC attachment. So here in our organization, the organization might have a requirement that on-premises network have full access to the VPCs, but the VPC be isolated from each other. In this case, you can configure your transit gateway multiple using multiple isolated routers. Okay, this is kind of similar of using multiple transit gateway, but it provides more flexibility in case where the routes and attachment might change. So is transit gateway attachment is associated with the route table. Attachment associated with one isolating route table can route to each other, but cannot route packets to or receive packets from the attachment another isolated router. So here is the summary. So side-to-side VPN creates a secure connection between an on-premises customer and customer gateway and an AWS virtual private gateway for VPC access. You can connect multiple on-premises network through a single virtual private gateway, and uses of global accelerator can accelerate your VPN connection, site-to-site VPN connection. So configuring multiple transit gateway routing table to isolate VPC to provide full VPN access. So the next part will be covered by the Pawan. Thank you, Pawan. You can continue.
Hello, this is Pavan Sakshat Garmella. So, Abir, shall I share my own screen?
Yes.
Okay. Uh, just a minute. Can you see my screen now?
Yes.
Hello, am I audible? Hello, Abir.
Yes, I we can see your screen.
Uh, okay, yeah, okay. So today I'm gonna speak about direct connection with AWS. So jumping into the topic. So coming to this, direct connection is a private virtual local area network, basically, also called as VLAN. So let us talk about this off the records. This is mainly used to establish a dedicated private network connection from your own um, premises network to AWS. This private connection extends your private network to include AWS resources and more provides more consistent network experience so that there is any disturbance with bandwidth or data transfer issues. So this helps to reduce more than 90% of the data transfer issues by increasing the bandwidth. Coming to the use cases, so um, yeah, just a minute. Let me move this side. Yep. So higher bandwidth throughout the ideal data transfer, lower latency. This also helps in lower latency, which makes consistent performance compared to the internet-based connection, means the public connection. So this is a private connection, as we already discussed. Enhance its security since traffic stays off in public internet. And Mm. yeah, so there are two types of connections in this: extended on a premises network to AWS by using direct connect. First one is dedicated connection, and the second one is hosted connection. Coming to the dedication connection, a physical fiber optic Ethernet cable is provided only for one customer. Coming to the hosted connection, shared physical connection between provided by the direct connect partner. Uh, and then coming again to the dedicated connection, direct link from your own prem router to AWS via direct connection location. Coming to hosted connection, more flexible bandwidth options, faster to provision. So basically, this increases the bandwidth for large data transfers and reduces the latency. Coming to the connection reach of these connections, although a direct connection is tied to an AWS region, you can access any AWS region using the service except China. And coming to the virtual interfaces in this topic, there are public VIF, private VIF, and transit VIF. Um, so this is the direct connect using transit gateway. In this, you can also direct connect to the transit gateway instead of virtual private gateway to simplify the route between on-premises network to a multiple VPCs. The transit gateway has a transit gateway direct connect attachment pointing to the direct connect gateway. The VLAN 3 the VLAN 3 is connected and established on-premises customer router to the direct connect location. So this is the direct connect location, and the direct connection location endpoint connects to direct connect gateway through the virtual transit interface. So this space is named as transit virtual interface, which gives the connection between direct connect endpoint and direct connect gateway. Then it is transferred to transit gateway, direct connect attachment. Then this comes into play. The transit gateway is connected to the VPC through the transit gateway VPC attachment. High availability direct connect and backup VPN use case. So coming to this, let me explain this in my own points. Uh, Combined direct connect, also known as DX, which is represented as DX as our primary connection with a VPN as a backup. So one via direct connect and one via VPN. So the routing and configuration of this is AWS prefers direct connect by default. So no extra AWS side settings are needed to prioritize it. As we know, you should configure internal route propagation to guide your internal systems on which path to use, the DX or the VPN. You can use either of the path. Mm, For higher availability, consider multiple DX circuits and VPN tunnels. The use of VPN is this creates a transverse tunnels to bypass and pass through the public internet connection and transfer the data accordingly throughout the server. And multiple DX locations also helps multiple AWS regions as we know, except China. And so high resilience with multiple direct connect locations. AWS handles the resilience in cloud backbone. So this is basically handled by the cloud backbone of AWS. You are responsible for resilience on premises and within your AWS resources. Redundant connectivity. Always provision redundant connections between on-premises and AWS. Use two VPN appliances. If one lacks built-in resiliency for direct connect, set up two DX connections from different locations. So we'll be using different connections to avoid lack in resilience, and we use VPN as a backup for DX. Mm, So the key takeaways connecting to our remote network with direct connect are these are the main points that we have spoken about till now. Direct connect is a dedicated private VLAN virtual local area network connection that extends on uh, premises network to include AWS resources. Using a private virtual interface to connect a direct connect location to a virtual private gateway. Mm, this interface to use this virtual interface to connect direct connection location to supported AWS services. Make your network highly available by using direct connect as a primary connection and VPN as a backup connection as we already discussed. Make your network highly resilient by connecting from multiple on-premises network to AWS by using multiple direct connect locations. And coming to the next topic, applying AWS well-architectured framework principles to network connectivity. Uh, so there are four main pillars in this well-architectured framework: reliability, security, performance efficiency, and cost optimization. So first, let us discuss about the reliability. Actually, it has six pillars, but these are the best practices that we are gonna discuss about. Coming to reliability. So when you design your network, you should plan a resilient network topology. Resilience implies that your network workload should function correctly and consistently when they are expected to. So this mainly focuses. So basically, we know what is reliability. We should be able to depend on the services when we are in need of it. So basically, that is reliability, and AWS provides that. This means resilience is shared responsibility between AWS and you. So provision redundant connectivity between private networks in the cloud and in on-premises environments. AWS recommends having a failover network mechanisms on premises and in the cloud when an interruption occurs. So when you connect your VPC to your on-premises data center through VPN, you should consider the resilience and bandwidth requirements that you need. If you use a VPN appliance that is not resilient, it in its implementation, then you should have a redundant connection through a second appliance. If you chose to connect your VPC to your data center by using direct connect connection, you need this connection to be connected to the second direct connection from a different location, so that if the connection interrupts, uh, the service don't gets disturbed. You can also use a VPN as a backup for a DC connection. I mean direct connect connection. Mm, Coming to security. Control traffic at all layers. This is the best practice, so let us go deep into this. AWS recommends establishing private network by implementing direct connection or a site-to-site VPN. So direct connection is the first option, and the second option is site-to-site VPN to protect communication, so that there is no data leakage or breach. The VPN creates a secure tunnel, as we already discussed, to traverse the public internet from an on-premises location to the AWS cloud. Direct connection establishes a dedicated private line from on-premises location to the direct connect location. In this module, you learned about the number of AWS network services that support these best practices, implement site-to-site VPN, and implementing direct connection for a private network. Uh, and there are some more best practices that have been noted down here: authenticate network communications and enforce encryption in transit. So coming to authentication network communications, AWS recommends verifying the identity of communications by using protocols that support authentication, such as TLS or IPsec. Using network protocols that support authentication establishes trust between the parties. Um, Authentication is very important because we should avoid unnecessary and unpredictable traffic into the network to provide our data from data breach. Enforcing encryption in transit. AWS recommends using protocols with encryption when transmitting the sensitive data outside of your VPC. Encrypting help maintain data confidentiality and credibility. Um, Coming to performance efficiency. So this is a simple topic as we know. This performance efficiency is basically choosing approximately sized dedicated connectivity or VPN for hybrid workloads. So this is basically explaining us about so how much connectivity should we take and plan before we do a workload or before we do a connection. So this is like estimating the traffic before we run the program or connect to the servers. Cost optimization. So AWS comes into main play in this cost optimization. So we should be selecting the components that are need to be running in the server. I mean in the services. So selecting the components only that we are gonna need is gonna optimize the data transfer cost. And implementing only the necessary services can also reduce the data transfer costs. In this module, we have learned the dedicated network connection, such as direct connect from an on-premises environment to VPCs on your AWS account in order to optimize the data transfer costs. Mm, so these are the key points that we have discussed in the previous slides. Um, Prefer hub and spoke topologies over many to many mesh. So this point explains us about the direct connect using site to site connection is much more preferred and control traffic at all layers. This is for the security. Authentication network communications. This is also in the security component we already discussed. And choose approximately size dedicated connectivity for VPN for hybrid workloads. So this is the size that we are gonna decide and dedicate for a particular connection for a hybrid workload. Choose your workload's location based on the network requirements. And coming to the module summary, this module prepared you to do the following. Describe how to connect an on-premises network to the AWS cloud. Describe how to connect multiple VPCs in the AWS cloud. Connect VPCs in the AWS cloud by you. So we already did this already in the lab. So and we already discussed in theory now. And guys, if you are watching this video, please try to answer these questions after the explanation. Um, Discuss how you should you as a cloud architect. My advise a case based on the key cloud architect concerns presented at the start of this module. So I think I will use uh, direct connect than the VPN in this case because we can take the orders without any latency deficiency and uh, yeah, it works. Module knowledge check. The knowledge check is delivered online within this course. The knowledge is 10 questions presented on the slides. Okay, coming to the oh, these are the sample examine questions. An application running on Amazon EC2 instance in a virtual private cloud VPC processes sensitive information stored on Amazon S3. The information is accessed by using an Amazon S3 public regional endpoint over the internet. The security team is concerned that the internet connectivity to Amazon S3 is a security risk. Which solution will resolve the security concern with the most efficient network route? So, the option EC2 instance in a VPC. Oh, sorry for the interruption. Yeah, EC2 instance in a VPC. Sensitive information, internet connectivity to Amazon S3 is a security risk and most efficient uh, network route. These are the keywords and phrases. So I think we are gonna keep identifying them in the coming questions. An application running through VPC process the sensitive information stored on S3 working root. And S3 is a security risk. Which solution will resolve this? The same question, I guess. So let me think. Access the data through the internet gateway. Access the data through the virtual private network (VPN) connection. Access NAT gateway. Access the data through a VPC. I think the option is D. So let us see. Yeah. So access the data through a VPC endpoint for Amazon S3. Option D is the best choice because use a gateway VPC endpoint for no additional cost solution without bandwidth and packet size limits. That's an advantage. And here our meeting comes to an end. And thank you. Thank you everyone for giving us this opportunity to present ourselves in front of you guys. Thank you, sir.
Thank you, Pawan.
So, my name is Chase, and we will get started on the lab for creating a VPC peering connection. The main goals of the lab is to be able to create VPC peering connections, configure route tables to use a VPC peering connection, enable VPC flow logs to provide insight on the data moving across the network, test a peering connection, and analyze the VPC flow logs. And this will be a rough idea of what our VPC should look like in a visual example. So, with that in mind, let's see. First, start the lab. Have to wait for that to turn to a green light. taking a minute to start up, isn't it? I don't know why that's not turning green, but it looks as if it has everything, or it should be all loaded in. I'm gonna give that another minute or so.
Just you can click on the AWS. It will work, no problem.
There we are. Okay. So after it finally turns green and the AWS server is up, open it up in a separate browser and arrange it so that you can swap between them a lot easier. That's so. A VPC peering connection is a one-to-one networking connection between two VPCs that enables you to route traffic between them privately. Instances in either VPC communicate with each other like they are in the same network. You can create a VPC peering connection between your own VPCs in a VPC in another AWS account or with a VPC in a different AWS region. The two VPCs are provided as part of this lab that we are going to go through, the lab VPC and shared VPC. The lab has an inventory application that runs on the Amazon Elastic Computer Cloud, EC2 instance, and shared VPC has a database instance that runs in a private subnet. So on said AWS Management Console, we are going to go to VPC Management Console. Go to peering connections. There, sorry, missed it the first time. Going to create a peering connection. Be naming it lab peer. This one will be, the requester will be the lab VPC and the acceptor will be the shared VPC. And then just create peering connection. Then go to the actions drop-down list and accept the request. We are now going to update the route tables in both VPCs to send traffic from the lab to the peering connection for shared. So go to route tables, select public.
Yes, we cannot see your AWS account.
Is that good?
Yeah.
All right. I guess it just has the one screen shared. I apologize. So I'll just swap between them like this. So after going to choose route tables, which would be the third option, we can then select lab a public route table. In the routes table, we're going to edit routes. We're going to add a route. So let's see, where is edit routes, add a route. Going to add this destination.
Chess, I think you overlap the another one.
What'd you say?
You did a mistake. Can you go to yes?
Oh,
Yeah.
sorry. Thank you for that. I appreciate it. And target is going to choose peering connection. There we are. Then set the, excuse me, set it to lab peer. All right. And save changes. Going back to the route tables. Going to select shared VPC, the shared VPC route table. Make sure the other previous one is not still selected. And we will once again go to routes, edit route, add a new route, and we will add this destination. Once again, going to choose peering connection and choose the lab peer and save changes. Now that the peering connection is established between the two VPCs, you can set up the VPC flow logs to monitor the network traffic moving between those two networks. And in this lab, we will set up the VPC flow logs to monitor the traffic on the VPC hosting database. So going to choose your VPCs, going to the shared VPC. From the bottom channel, choose the flow logs, and we will create a flow log. Going to put in the name shared VPC logs. Make sure the maximum aggregation interval is 1 minute. Going to change the destination long group to shared VPC flow logs. For the, let's see. Then for the IAM role, choose the VPC flow logs role. There we are. And create flow log. Then, yep, flow log was created. Go back and check the flow logs to see that shared VPC logs was created, just to make sure. Then you're going to use the hyperlink that it brings for VPC flow logs, for shared VPC flow logs. And that should Oh. So it says it exists, but since we just made it, might just have to wait a couple minutes and refresh it. May take a few minutes. Gonna give that till about, or give that a couple of minutes, and hopefully by that point it should have it made. There we are. Alrighty. And we'll be keeping that window open in the background. Now that you've configured the VPC peering, you will test the VPC peering connection. You will perform the test by configuring the inventory application to access the database across the peering connection. From the top of the guide, choose AWS details. Copy the value for the EC2 public IP. And we will put it into a new web browser tab. Go to settings and configure the following settings into endpoint database username and password. So grab the endpoint from AWS details. Database is inventory. Admin and lab password. Make sure everything's capitalized as it should be. And save. The application should now show data from the database. And we did this to confirm that the VPC peering connection was established because shared VPC does not have an internet gateway. The only way to access the database is through the VPC peering connection. Next, we will analyze the VPC flow logs to understand the traffic between application and database in veered VPCs. To start, we will go to the browser tab or window that is displaying the shared VPC flow logs. It should be, this one. Select log stream NEI. All right. It should have traffic patterns in the logs. It should look like the following, which we do. There may be a lot of lines that show up in the log, but we're just going to analyze the few lines with port 3306. This represent, or the ones we're looking for, the ones with port 3306, as that represents the traffic between the application server and database, which we do. here and here. Then with the AWS account ID, the network interface shows the ANI, the Elastic Network Interface ID on which network traffic is recorded. The from IP is the private IP of the database, the to IP being the private IP of the IP of the destination where the EC2 instance is running. The port 3306 is the RDS database, and then action for accept or reject and whether or not it's okay. They are. And then with that, you will have successfully created a VPC peering connection, configured a route table to use the VPC peering connection, enabled VPC flow logs to provide insight on the data moving across the network, have tested a peering connection and analyzed the VPC flow logs to understand what data is actually being tracked. After that, once you have finished, you can choose to submit to record your progress when prompted. Click yes. I'll take a moment to submit. There we are. And then once it's submitted, don't forget to end lab. And after that, you'll have finished the lab. Does anyone have questions?
No, thank you.
Right. With that being said, thank you everyone for following, and I appreciate your time.